So I want to give a real world example of what I did and how I use technology in the classroom. So yesterday our essential question was, how can we find inscribed angles within a circle? The content objective is I will find measures of inscribed angles by using the inscribed angle theorem, and I will justify my answers by speaking to a partner. So this is just general, general content and language objectives. Now, my objective for the day was different than my team's in that I incorporated technology with it. Yesterday, I had my students go to Desmos.com. They selected math tools, geometry tools. Now, the objective is to find the inscribed angles within a circle. Now, the way we do that is I had them construct a circle, and once they had the circle, they could pick whatever size they wanted, but what I wanted them to do was construct 2 points, and those 2 points create radii, so plural for radius. This is called a central angle. Now, we've talked about central angles, however big they might be. If it's 77 in the central angle, the arc is also 77 degrees. Anyways, the point of inscribed angles, though, is if two chords are connecting at a certain point, and I go to measure this inscribed angle down here, and I had them doing all of this in the class along with me, but at a much slower pace, obviously. I asked them to construct this and manipulate the diagram and see if they noticed any special relationships between the angles. So right here, I've got an angle that's 80, an angle that's 40. If I change the central angle to a 90-degree angle, this is 45. If I change this to a 100, this inscribed angle is 50. And so that got them noticing, oh, okay, it's always half. Even if I make it bigger, it's always going to be half. The inscribed angle is going to be half of the central angle that it creates.